All right, so let's look at how we plot our points. So make sure you do your, so what they are using now, they're using 5, this is a scale of 2 centimeters, so this is 5 centimeter representing 2 centimeters. While on the y-axis we have thick line, thick line, thick line. So this is 5, the same scale, 5 units, 2 centimeter representing 5 units on the cumulative frequency axis, and 2 centimeter representing 5 units on this axis. Take note, it's not starting from 0. That's why there's this little zigzag. Now start plotting your points. When it's 59.5, you have 2. 59.5 is somewhere around there. 2 is somewhere around there. When it's 64.5, is 7. All right. So when it's 69.5, 69.5 on the 69.5 against 19. So 69.5. This is our 69.5 should be here. This is our upper class boundaries. 69.5 is somewhere around there. 69.5. So against 19. So 19 like that. So plot all those points like that. All of these against this. 2, 7, 19, 39, 47, 50. You have no business with this. This is what you're going to use. So, and this is all on your y-axis. This is all on your x-axis. All right. So by the time you plot it, you now join them together with, of course, you know how to join a curve. Either use a French curve. So we have plotted our curve. We have our curve here. All right, neatly done. Now, to find the median, remember your formula for median. Median is n plus 1 over 2. N in this case is total frequency. The total frequency you can get is 50. So 50 plus 1, that's 51 all over 2. So 51 all over 2. 51 all over 2 is going to give us, so this is, they call it a median. 51 over 2 is going to give us 25.5. All right, so 25.5. So go to 25.5 on the cumulative frequency axis. 25.5 is somewhere around there. All right, so 25.5. So trace this 25.5. So trace it there and then trace it down. So where it touches your curve, that's why I say this curve must be accurate. Where it touches it, you now trace it down. So we get that that's called Q2. So you read it's roughly 71. Roughly 71, you get 71.5 is our median. To do the same thing for Q1, there's Q1 and Q3. Q1 is called the lower quartile. So it's 1/4 of your total frequency. And if you do that, you get 1/4 of total is 12.75. All right, so you come here, look for 12.75, somewhere around there, 12.75. Trace it where it touches your curve. You trace it straight down. You read off that value. It's gotten as 7.5. The same thing you do for Q3. All right, I was trying to talk about the semi-interquartile range. Semi-interquartile range is the upper quartile, that's third quartile minus first quartile. So Q3 minus Q1. What is Q1? Q1, I've explained Q1. Now Q3 is just upper quartile. They call it Q3, upper quartile. This is Q3. All right, Q3. So it's 3/4 of your total frequency. If you do the calculation for that, you get that 3/4 of 51 is 38.25. So you come to your cumulative frequency axis, look for 38 points. So 38 points is somewhere around here. You trace it. Where it touches your curve, you trace it straight down. So you get Q3 as 74.8. So do that calculation, you get that. All right, so this is our cumulative frequency table. We are going to use the upper class boundary here, this column, as our x-axis, okay? And then we'll use the cumulative frequency column on the y-axis. So it ought to be labeled cumulative frequencies. And it's supposed to be a length upper class boundaries. All right, so they also have labeled it. So now let's look at, so when it's 59.5, now you see it's not starting from 0. That's why you have this thing, this zigzag, all right, this zigzag. It's saying it's not really starting from 0, okay? On the horizontal axis, of course, all this go in the horizontal axis, right?